This is Unit 1, Lesson 5. Oh, I have to change the name of my lesson. I made a mistake there. This is constructing a square, a equilateral triangle, and a regular hexagon. All of these figures will be inscribed in a circle. So this video will go over the vocabulary, the new vocabulary for the lesson. The next 3 videos will go over the example and the practice. So the first term, which may be new to you, is what is an inscribed polygon. That is a polygon where all of its vertices lie on the edge or circumference of the circle. You can have polygons inscribed in other polygons, but the concept is still the same. All of the vertices, which again is a plural for vertex, must lie on the edge of the figure. So notice all these dots that I'm making, those are the vertices or the angles of the figure. Those angles all must lie on the edge of the circle in order for it to be considered inscribed. Okay. It is said that the circle circumscribes the polygon. So when the polygon touches all the edge of the circle, it is completely contained within the circle circumscribes those polygons. Circumscribe, we will see that term later when we talk about circles. A circle can also be inscribed in a polygon. Though a circle doesn't have any angles or edges, the widest points of the circle, so there should be 4 points, touch the edge of the polygon. So a polygon can be inscribed, a circle can be inscribed in other polygons as well, as you see in these 3 images. The widest parts of the circle touch the edges of the polygon. Right? So for as many sides as it has, that's how many points in which the circle needs to be touching or completely contained within that figure. So notice here, the circle touches all 5 sides of the pentagon. It is completely contained within the pentagon. For our purposes, for this particular lesson, we are going to be making figures contained within a circle or inscribed in a circle. The other term that may or may not be new, in yesterday's lesson, lesson 4, you talked about regular hexagons or regular polygons. Today we will be inscribing a regular hexagon or an equilateral and equiangular hexagon inside of a circle. So again, regular means all sides, all angles equal, which again is what equilateral, that means equi is equal, lateral means sides, and equiangular, equi means equal, angular means angles. So a regular hexagon is a 6-sided polygon with 6 congruent sides and 6 congruent angles. Squares, you're probably familiar with seeing squares, however you might not be familiar with the formal definition of a square. A square is a polygon. More specifically, in this course we consider it is a parallelogram. We'll talk more about that when we discuss quadrilaterals. But it is a parallelogram with 4 congruent sides, 4 right angles, and whose diagonals are perpendicular. And the diagonal piece is the piece that allows us to do the construction within the circle. Right? So a square is a regular figure because, again, it has those congruent sides, it has those congruent angles, and the important part of the definition of a square is, or properties I should say, is that the diagonals are perpendicular. So that is the piece we're going to use in the construction of our square inscribed in a circle. And that is it for vocabulary.